Okay, so who here has had any training or used a Docker before? Oh, okay. Looks about like a third to half of the room. Okay, great. How many people here think they will be using Dockers? Great. And just to let you know, everyone has been using Dockers because they are part of the underlying architecture, what's happening in Terra. So I will explain that a little bit. You know, why you would need to know this if you want to become a super user on Terra. Like, it's not necessary to know this, but it certainly is helpful as you go back to your labs and you're designing your own experiments. But I'm going to start at the beginning so that we have a better understanding of what the Docker is and how it is operating. So this is how we used to do large-scale compute. We would load one application into a machine and launch it. I remember I used to have to reserve time on the Linux server at my university, the Linux server in the server room, and go in and log in, load my program, and then run it, and then unload the program and leave after I got my outputs. So it was very slow. There's lots of cost. The operating system was fixed. It was difficult to scale or migrate. There weren't other servers in the room. There was one. And then there was a lot of maintenance cost, you know, to maintain that. And it was kind of, a lot of money was being spent to have a computer that wasn't being used optimally. So now, in this new world of the cloud, we have come up with machines that are scalable, meaning that you can have many machines running simultaneously. You don't have to go to a specific place. And you can customize based on whatever operating system you want, and you don't have to pick one. So I could have a virtual machine, meaning a machine that's not physically present in front of me, that is running a Mac operating system. I can have one that's running a PC operating system. And I could be subdividing my jobs based on what each of the machines does or does not have loaded. So that is what we're kind of doing when we talk about cloud computing. We're just creating machines with the characteristics that we like and sending our jobs out. And a lot of people like this because you don't have to pay all those maintenance costs. You don't have to go to a room. You don't have to have earthquake-proof floors, things like that. You know, you can just have machines created and pay as you go. So this is a schematic that shows how it's different now. You can have one big piece of architecture. So this is kind of what, you know, Google and Amazon and Rackspace and all these cloud companies are providing for us. They're maintaining the architecture and all this infrastructure, and then we build on it. So we can build, you know, how many machines we need with all the different operating systems and things like that. But for any of you who have been frustrated by starting our notebook runtime, you realize when you create a virtual machine, there is a cost. Even though this is easier and less of a lift than having physically present machines, it still costs in time and in money. Because if you spend a lot of time loading programs instead of actually doing your research, that's frustrating, right? Like, you know, it may take you half an hour to load all the scripts that you need to do an analysis that takes 10 minutes. Who wants to pay for that half hour? So that's where Dockers started becoming fashionable. As we began to scale up and start asking for more virtual machines and compute time, we didn't want to spend our money and time on waiting for programs to load. So Dockers give you a little bit more flexibility because it's like having a virtual machine with a preloaded set of programs. Like, you already know, I'm going to open up this machine. It's going to contain my Microsoft Office, my Microsoft Windows, you know, like whatever, the Microsoft Windows suite already. I don't have to sit there and load it myself onto the machine. So that saves you time and money. And it's different from virtual machines because virtual machines is really about infrastructure, whereas Docker containers can use you can have one virtual machine running multiple Docker containers, for example. So they don't scale exactly the same. So here's a schematic of how Terra and Google Cloud Compute has combined the versatility of Dockers with virtual machines. So for example, I have got 1, 2, 3 virtual machines here running 4 different applications. So I've got the traditional virtual machine model where there's one operating system, and then I've got one application running. And then over here, I've used a Docker, so this might be slightly faster running this application, but I could have one virtual machine with a Docker on it running 2 applications simultaneously. So it just increases the versatility and flexibility of your compute and saves you those minutes and dollars. That's what we really care about. So using Dockers helps us scale our compute. It also is a more efficient use of the cloud. We don't have to store our Dockers locally. We can have our Dockers be in the cloud too. So all this stuff that we carry around with us, like in our book drives and on our USB sticks and things like that, like you don't have to worry about that. Like everything's up there in the cloud, and it's cheaper and faster to connect something that's already in the cloud with something else that's already in the cloud. If you've ever had to wait to upload a bunch of stuff, you know what I'm talking about. It also allows you to encapsulate exactly what you use to get your analysis done. So journals might be moving towards this model. They might be asking you for, and I don't know if has anyone submitted to a journal, GigaScience likes Dockers. They want you to send them the Docker you use to do your genome assembly, because it shows, oh, I used, BWA version 1.7 and SAM tools 2.7 and R version 3.5. It's all in there, and it's static and it's capturable. It's something that somebody else can go to the Docker registry and pull it back out and replicate your research. So this is moving towards that ideal that everybody wants: repeatable, reproducible, accessible methods. How many times have you gone and read our science paper and they've mentioned, oh, we have a custom Perl script that gets you from point A to point B, right? And then you ask them, like, where's that script? Where is it located? And it's gone because, oh, the grad student wrote it for me, and I have no idea, where that thing went, right? If it's in the Docker, I can reproduce this analysis now. So Dockers are great for really reaching that ideal that we're working towards with tools exactly the way they were the day that you ran them, with scripts that you wrote to help your tools run and allow someone to check it out, find it, and check it out. So it sounds complex, right? Sounds like Dockers should be something that is relegated to people who have computer science, advanced degrees. No. Dockers actually are cool in their simplicity. If you can handle WDLs, you can handle a Docker. It's just basically a text file that you write saying all the cool stuff you want to put in there and you want to save and you want to have kept in the Docker. And then that builds, you use just a simple command called docker build. You build the image, you can use the image, and then when you're ready and when it's optimized, you can put this image into a registry for other people to use. Okay. So the kinds of things you want to put into a Docker container. There's things you do and do not want to put in a Docker container. So any scripts or executable files, yes. Any dependencies that allow those scripts and executable files to work, or like specific software specific to your lab. But sample data, no. So I usually pause here because it gets to be the middle of the afternoon and people are kind of falling asleep, and just have you guys talk for a minute amongst yourselves and then tell me, why would you not put the large data sets in a Docker?
That makes the image bigger.
Makes the image bigger. So the advantage of a Docker, the portability, is lost because then you've got all your data in there and it takes a while to load before you can do the analysis. Other reasons. There's a word up here that kind of private, right? You don't want to put any patient data. We have a hard time with that, like making sure it's CLIA compliant, that we're not accidentally exposing people's personal data. So what do you put in a Docker? You put in enough information to allow somebody to make sure the Docker is running correctly and nothing else. I mean, honestly, that's what I'm going to say. So I'm just saying limit it to small test data sets. And so if you notice, like in our Terra featured workspaces, we kind of treat them like Dockers in a way, because we're giving you little snippets of data that do not require authorizations, it's publicly available to use, just to make sure the thing's doing the thing that you think it should. You know what I mean? So it's a good idea just to have that in the Docker. Saves money and time. You don't have to wait for all that data to get loaded when you create the Docker, preserves privacy, and where is our data then? Like if it's not in the Docker, where's the data? Where do you guys keep your data? Buckets, flash drive. We're trying to move away from flash drive. Buckets, Google Buckets. Anyone here on Amazon Cloud? It's okay if you're on S3. I mean, I have stuff all over the place out there in the cloud. It's kind of scary. Dropbox, Google Drives, right? So the thing is, if you write the Docker, if you have the Docker here, then you don't have to worry about all the data being together in one place. You can write the Docker so it can be more portable, right? Yeah, and interoperable, they like to say that. Okay, so you may not have to write your own Docker. You can certainly find Dockers. They're getting very popular now. So usually the first step of making a Docker image for yourself is to find a Docker image really similar to what you want to do. Say I want to do something in R and I need to add some special scripts. I just usually go grab the R base one. And then they're out there. And so we have in our platform the ability to bring in any of these Dockers from Docker Hub, Quay.io, or Google Cloud Registry. One of the main differences is Docker Hub is public and available to everybody to see, whereas I think Quay.io, if you pay, you can lock them down, and Google Cloud Registry are mostly, you can make them private also. So you really just have to be considerate of, like, if I'm developing a new method and I don't want people to see my Docker yet, like if that's something I'm going to publish about as a bioinformaticist, you might want to use one of the registries that keeps your data, or keeps your Docker, your method, actually private. So, like I said, it's more efficient usually to start from an existing image and then build upon it instead of building one from scratch. But it's really up to you what you like to do. And then you can use Docker images in 2 different ways. And actually, you're using them in 3 different ways on Terra. You can use them interactively, or in a WDL workflow, or actually in notebooks. You're using a Docker. But here's just going to give you a few basics. I'm not going to dwell on it too much, but I am available through the Terra help desk if you need help with any of these questions on how to build a Docker. So I had a lab that needed to run a script that relied on R, and we were trying to convert it into a WDL. So if you've looked closely at WDLs, there is a place to pull in a Docker and run your analysis through a Docker. So this person needed to have a script that used R. So there's an R-based Docker called rbase that's maintained by the people who write R. And you can go get the latest version of rbase, and then you can add your scripts, and then you apply a command to let people know how to run the script. So if my script is called my scripts, then the command will be rscript myscript.r. But it kind of follows very simple syntax, much like WDLs do. It doesn't take very long to learn how to build a Dockerfile. And then once the Docker is built, once the Docker file is written, so this is the text file. It may just have 1, 2, 3, 4 lines in it. You're not going to have the bullet points. You build it by running something called Docker build, and then usually you have a place to put it, so a repository, your Docker Hub. And then you might want to tag it. You might want to say, this is the version for May 22nd, 2019. Usually having a nice tag is good, but we have a GATK Docker that we use for our workshops and for production level GATK that is exactly like this. When they're ready to push it out for the real world, they use Docker build which I think is saying go to the repository that's under the BroadE Institute called GATK, and this is the tag. So the tag in this case for GATK is the version, so it runs it. And then when I'm ready to run it, so say I want to borrow the Docker and I check the Docker out, and I could either put it on a virtual machine in the cloud or I could bring it down to my local machine, I can run commands from this Docker just by saying, hey, I have a Docker on my machine, let's run it interactively, and it happens to be from this repository, BroadE Institute, and this is the name of it with the tag, the version. And if it's not on my machine, it'll just download it for me. It'll be like, oh, you don't have that one on your machine. Let's pull it for you. So it's really neat. It's very simple to use Dockers if you know the repository and the name of it and then the version that you want. So this is what you would put into your paper, for example. You'd be like, oh, if you want to rerun this analysis, this little piece here is what you tell people, and then they're good to go. They should be able to pull it to their local machine or a virtual machine and run it. I may want to have a file on my local machine that gets output from the Docker. So Docker is like a little virtual environment. It doesn't see your machine unless you tell it you want it to see the machine. So any inputs and outputs that are done while you're working inside the Docker need to have a place to land that's outside the Docker. That's what this little tool lets you do. It's a -v parameter. It means mount a volume on my local machine. That is, my path, my data. That inside the Docker is called data also. So that anything that gets output to this data file automatically gets saved to your local machine. Otherwise, because Dockers are not, the Docker file structure is not visible to your local machine, and that is the biggest difference between Dockers and singularities. So I don't know if anyone's heard of Singularity. Anyone? Oh, it's another type of container that a lot of people find popular, but really the biggest difference is Singularity automatically mounts your local file structure, so you can see your local files. But unless you do this, you can't do that in a Docker. Biggest difference. But that's okay, that's for security. That means you can have whatever operating system, whatever kind of fancy script with whatever kind of parameters that's spitting off files inside that Docker happening and not affecting your local machine. That's why you would want to do that. And then here's a more extensive version of what a Docker file might look like. So this would be using the GATK Docker, or actually OpenGDK, that's a Java Docker. So from this original Docker, which is found somewhere out there on the web, I want to make a working directory called user, right? Because most programs install to user. And then I want to make sure I update and upgrade any of the files that are required for RBase. And then in addition to that, I want these specific R packages to be loaded into this Docker. And then you might want to copy a file that you need into the user thing. Okay. So it doesn't make a lot of sense to you actually sit down to do one. We're not going to have a hands-on tutorial today. I'm sure we are thinking about working towards having hands-on tutorials. But if you take our GATK workshop, you do use Dockers because we use the GATK Docker to load the information to your local machine to make sure it's consistent. If I know it's 4.12.0, I know when I'm talking to you and everyone's using that version, you're having the same experience. And I just have a couple little more slides just to explain, when I said you're already using Dockers, you use Dockers today, congratulations if you didn't feel like you'd been using them. And I'm just going to explain a little bit about what that means with 2 short slides. So a workspace that is using a WDL to send commands out to our little pig, the flying pig, Cromwell, is actually using a Docker to do that. Because if I need like 50 machines with exactly the same programs loaded so I can run my process on them, there's nothing better to do than use a Docker to do that, right? Like a Docker is a small little thing that I can send out to 50 different machines that are running simultaneously, and generating my data. They're all going to be identical because I used the virtual machine and the Docker to create them, preload all the packages. So that is exactly what is happening every time you're loading a WDL that uses a Docker. Right? It generates that consistency across the platform. So that's one way you're using a Docker already. And if you used a notebook today, you actually pulled a Docker called Leonardo Data Biosphere that created that web-based interface Jupyter Notebook. So Jupyter Notebook is just a program, but in order for it to work and have a web interface so that you guys can see it inside Terra, we need to have it done in a particular way every single time. So when you're clicking on the button to create a notebook runtime, you're really creating a virtual machine that then goes and pulls a Docker that contains all the material that is needed to spit out the notebook. If it didn't do that, you would just have a blank virtual machine. That wouldn't be fun for anyone, right? Like, notebooks are really fun. But that leads to why your data isn't seen. So remember I said you need to mount a directory in order for your files to be seen by your local file infrastructure. We don't do that for you. We want you to be able to use your notebooks and play around with ideas and not feel like all that stuff is like permanent. But if you do hit upon outputs that you really, really like, you need to write a little bit of code into your notebook. And this is written in a knowledge base article about saving and transferring data files between notebooks and your workspace, just to make sure it gets saved. So your code is always being saved, but your outputs aren't. So you just need to be careful and make sure you understand that before you dive in and start using these Jupyter notebooks, which are Dockers, so they're not seen by the local file infrastructure. But it can save you money too, you know what I mean? Like if you're just playing around and you just want to use your machine and stuff like that, and you don't want to have to save every single permutation into your Google bucket, which costs money, you don't, right? You can just save the part you cared about at the end. And then also bringing in data, it's not automatic. You need to be able to set some environmental variables, and the data doesn't have to come from just your workspace. You can have data coming from other locations too. But that just gets into knowing a little bit about programming and how to bring files into the workspace and work on it and push it back out again. But that's it. I just wanted to mention that everybody can go home now and brag about being Docker users all day long. So that's it. So if anyone has any questions, I'd be happy to answer them.